Hi, my name is James. In this session, we're going to be exploring the TypeScript language. We're also going to check out the new JavaScript editor that's part of Visual Studio 2017. And then we'll take a look at what it takes to migrate an existing JavaScript project to TypeScript. I'm going to assume that you know a little something about JavaScript and you have some experience with Visual Studio. My name, as I mentioned, is James Churchill. I'm a teacher at Treehouse. Treehouse offers online education for beginner, brand new developers, and experienced working developers who want to keep their skills updated. I have about 16 years of professional development experience, mostly working as a consultant doing web development. I've also been a regional speaker and trainer for organizations throughout Oregon, Washington, Idaho, Utah, and recently Tennessee. Our agenda roughly looks something like this. We're going to start with a basic introduction, kind of lay out the premise for what we're going to be doing here. And then we're going to jump into some demos. We're going to show off the new JavaScript editor in Visual Studio 2017. Then we're going to take a look at the TypeScript language itself and some of the basics there. Then we're going to finish up by migrating a JavaScript project to TypeScript. So let's start with our introduction. So imagine, if you will, that this is what our current situation is. So we have a code base on our application that we've been working on as a developer that has organically grown over months or maybe even years. Now, the code in our code base is relatively clean. We've done a good job maintaining it. But even so, we kind of are afraid to make anything other than a minor change. Now, if you're not careful with JavaScript, JavaScript can become what's called a write-only language, meaning that it's possible to write JavaScript that really, it can be written, but it's much more difficult to understand and read, which is kind of what you need to do if you want to be able to make a change. Now, this is especially true if you don't have good unit test coverage or decent tooling support. So what do we need? Well, kind of stating the obvious, we need better tooling. We need something that's going to help us to prevent simple mistakes. I don't know if you're anything like me, hey, the typos, they happen occasionally. So we need tooling to make sure that we don't make those kinds of silly mistakes. We also need improved code discoverability and navigation. If we have a large project with dozens or maybe hundreds of files, we want to be able to find the code that we're looking for or how it's been consumed and used in our application without having to hunt around or do string find all search matches. We also want support for refactoring. If I want to rename something, again, I don't want to have to be searching for strings throughout our application and guessing, is this something I need to rename? We also want to be able to leverage new language features. JavaScript is being updated on a fast, regular cadence now. We want to be able to use those features without necessarily worrying about if they can be supported or are supported in the browsers that our users are using. So what are some possible solutions? What are some things that we can do? Well, probably an obvious answer, like I mentioned before, is we can use testing. We can use unit testing and integration testing, and that can really go a long ways to help improving our code quality and provide, really importantly, the safety net for refactoring. We can also look to use some tooling. So tools like Babel, for instance, can be added to our development workflow so that we can start using newer JavaScript features today without having to worry about whether or not they're implemented in our browsers. And we could also consider adding static typing, which leads right into TypeScript. Static typing really helps light up things inside our development and our editing experience. But what is TypeScript? Well, TypeScript can be described simply as the sum of three things. First of all, it's a superset of JavaScript. TypeScript is not trying to inherently change what makes JavaScript great. So TypeScript starts from the same syntax and semantics that JavaScript has today. And then it adds on top of that to do the things that it needs to do, like add optional static typing. So the optional static types, the type system doesn't go beyond, or doesn't really go beyond what's built in JavaScript. We still have our basic string, number, Boolean, date, array, data types that we would expect to have in there. And we'll see an example of what that optional static typing looks like. But having that static checking and code compilation really makes things happen inside of the editor that you're going to love. And then lastly, features from the future. So this is like what Babel does, in that we're able to write JavaScript code using new ECMAScript 2015, 2016, or even 2017 proposals and have that down-compiled to ES5, for instance, so that it can be used in a wide variety of browsers, even older browsers. We can go all the way down to ES3 in some cases if we want to, if we needed to. Now, another common theme that we're going to be talking about here today, you'll keep hearing me mention this, incremental migration. The idea of moving our JavaScript project to TypeScript doesn't have to be an all or nothing proposition. We can migrate as we have the time or that we need or want to. Now with that kind of laid out, let's jump right into our project and take a look at what we have set up here. So I have an app that I've called Visual Studio Releases. I needed a simple data set, so I put together a data set that showed the various versions of Visual Studio that have been released over the years and the supported frameworks and the frameworks that they supported. Let's go ahead and just run the app just so you can see what it does. It only has a single page, so there's just a single index.html page, and once our application starts up here, we'll see what that content looks like. And here we are, Visual Studio versions, starting with Visual Studio 97 to Visual Studio 6, onto Visual Studio.net, multiple versions, and then we get into the newer versions. As you'll notice, the list of supported frameworks just keeps getting longer and longer and longer. Onto, released yesterday, Visual Studio 2017. So this is our application. I'm using an ASP.NET Core project. This could be done inside of a regular ASP.NET project as well, but I love Core, so that's what I used. And all of my files just live in the www folder, which is where our static content is publicly served from. I did bring in, I'm using Bower to bring in a reference to jQuery. I'm really kind of only using jQuery in one little place, but I wanted to show what happens inside the editor with external libraries, so I brought in jQuery. We have some models, so we have one model called version and another called framework, and then we have a data.js, which is where all my data is being defined, and then we have an app.js, which is consuming that data, building up a string, and then writing that to the DOM. And we have a single HTML page. If we look at our HTML page, it's pretty simple. It basically, our hook to our application for our content is this div with an ID of versions. That's where we're appending our content to the DOM. And I'm not using bundling or anything sophisticated like that. I'm just adding in a bunch of script includes to bring in the JavaScript files that make up our application. If we take a look at data.js, you'll see that this is just a single getData function. And it's even just defined out here, hanging out here in our global context, which is a bit of a no-no, but again, we're keeping it simple here, and if we have time, we'll see how we can actually use TypeScript namespaces to fix this. But here we are, we're using the ES6 or ES2015 const, meaning that this variable is a constant and its reference shouldn't be able to be modified. We're newing up a version, which is a class. Now, what if we wanted to go look at that class? Well, look at this. We can hover over this and we're getting some IntelliSense, a tooltip pop-up. And this is giving us information about the parameters that we need to pass into this constructor. So we can see here that it expects a name parameter, code name, version number, and release date. Even better, we can put our cursor on there and press F12, and even though I didn't have the file open, it takes me to where that constructor is defined in the version.js file. Now something that I want to point out here is that we're not having to use file references anywhere in our project in order to make this happen. In previous versions, we had that file that either you were adding references at the top, which were basically code comments to say like, hey, there's JavaScript over here that this file is also going to refer or consume. We don't have to do that anymore. We can also Alt F12 and we get the ability to peek the definition. So we don't even have to leave the context of our current file in order to see where that's defined. In fact, this is not just a pretty picture. We could actually make changes to our code here if we wanted to do so. And then we can press Escape to close that window. Now, if we go back, Actually, you know what? Let's take a look to see where getData is being used. So I'm going to put my cursor on there, press Shift F12, and down here we get find symbol results. You'll notice that it found two locations. In app.js, it looks like we have a line of code that says const data equals getData, and we can double click that, and we're taken over to app.js file right where that function call is being made. Or we can click over here and go to the definition. Now again, our project here is sort of necessarily small so that we can, in the time that we have allotted for this module, we can kind of grasp what's going on for our app and work with it. You need to kind of use your imagination. Imagine that this project was 10 times, 20 times, 30 times bigger than it is. And imagine this function, single function is called from dozens of other places. Shift F12 to find all references would display them all in this list down here under Find Symbol Results, which is super helpful as a way to be able to navigate around in your project. We can also do Control-T or Control-Comma to pull up the Go-To dialog. And here, so for instance, let's say if we wanted to go find our framework file, we can open it up that way. All right, the last thing I want to show, because it's really cool and super helpful, is let's do a naming, a renaming. So I've got my cursor on getData. I'll go ahead and close the find all symbol references here, and I'm going to press Control-R, Control-R. And that brings up the rename refactoring. And I'm just going to creatively add a 2 to the end of this and press Enter. And you'll notice that as soon as I did that, real quickly, the app.js was flagged as being dirty and then was saved. And look at that. The caller was also updated. Pretty slick. Now again, there was only the one reference, but imagine there was multiple files in our project and that reference that. They would all get updated. And this is symbol-based. It's not just looking at magic strings. You can really kind of drive home that point by, let's say we wanted to rename this name property. Actually, let's go over to version. It also has a name property. Well, if we were to select that and do Control-Shift-F to find all, oh my goodness, look at that. I mean, how many times has that happened to you where you go to find a very commonly named something, and look at that, there's tons and tons of references inside of jQuery itself. Just keep scrolling down, and maybe we eventually find the one that we're looking for. Maybe we don't. Maybe we give up and decide not to change that property after all. But with symbol-based refactoring, we can rename this and change just the one that we intend to name. And if we come back over here, notice that there was no confusion whatsoever about this property also getting renamed. Pretty great. I'm going to go ahead and change that back because name 2 is a little ridiculous. Okay, so how is this working? Well, as it turns out, TypeScript is more than just a compiler. There's also what's called a TypeScript language service. In Visual Studio 2017, the new JavaScript editor is using the TypeScript language service to look at our code and understand all of the JavaScript code that's in our project to be able to give us this great IntelliSense experience. If we come back here to our app.js and look at this function call a little more closely, actually, let's do one that has parameters. So if we come over to Data, and let's look at Add Supported Framework. So if we zoom in here and look at Add Supported Framework, notice that there's 2 parameters, name and version number. And notice the colons after the parameter names. It's name : any and version number : any. Well, the any, that's the data type that's expected to be passed to this function. Any means exactly what it sounds like. We could pass any data type. Well, that's probably not what the author of that method intended to have happen. So let's put our cursor there, press F12 to go to definition. And let's see if we can add some clarity to our code. So we're going to add a JS.comment. JS.comments, so I did a /**, and look at that. Visual Studio was super helpful, and it already kind of like pre-populated out my JS.comment for this function. So I can give it a nice description here. So I can say adds a supported framework. And then we have param and curly braces any, and it's not any. So name, as it turns out, should be a string. And version number should be a number. And you'll notice that if we come down here and hover over the parameters, now IntelliSense is able to tell us that this parameter called name should be a name, or should be, excuse me, a string, and version number should be a number. Even cooler, if we come back out over to data.js, now notice that when we hover over add supported framework, we get IntelliSense here telling us that name should be a string and version number should be a number. So that's really helpful. It gives us a way to clearly be explicit about the intent, or to express the intent of our code, which makes it much easier for others to consume and use. So having that kind of rich IntelliSense support is pretty cool. But you might wonder, well, what about external libraries? How does that work? So let's go over to app.js. And again, like I mentioned before, I'm using jQuery, but I'm just using it to append to the DOM. Not really a very interesting usage, but check this out. If I hover over the static $sign for jQuery, we're getting IntelliSense that tells us that it's the jQuery static, and furthermore, what we can pass into here, specifically a string that represents the selector. Same thing, if we come over here and hover over append, we're getting rich information about how we can call that method, and if there's overloads available, and with jQuery there typically is. Yeah, there's one other overload. So that's really great. That begins to show you the power of this new JavaScript editor and how it can make our lives easier. And this works across many, many different external libraries. So anything that you've referenced, for instance, if you're using npm for package management for client-side packages, anything that's been added into package.json will get, the types will get automatically loaded in. It also works the same for Bower. It even goes so far as to look at loose files that are part of your project, and there's just a matching in approximately 400 popular JavaScript libraries. And we'll take a look a little bit later about how or what these definition files are, but they're basically TypeScript type definitions that get loaded in that help IntelliSense light up and give you information about the code that you're trying to call into. Okay, so now that we've seen some examples of what the new JavaScript editing experience is like, let's take it a step further. And what we're going to do now is that we're going to add what's called a tsconfig.json file to our project. And again, just as a reminder, our files currently are in a scripts folder that's located inside this www root, which is where all of our static content for the ASP.NET Core website lives. Well, I'm going to right-click on our project, and zoom back out here so I can pick this correctly. I'm going to say Add Folder. And then I'm going to name this folder Client. And then I'm going to take the models folder and the app.js and data.js, and I'm going to drag it over here into client. So I'm moving it out of the www root folder. These are going to become our source input files. Then I'm going to right-click on Visual Studio Releases Project, and we're going to go to Add, New Item. And I'm going to add it could be a JavaScript, it could be a JSON file, and we're going to give it a name. It has to be named this, tsconfig.json. And this is just a regular old JSON file, so the syntax will feel familiar, but the naming is special. The naming is special because the TypeScript compiler that Visual Studio is using to compile TypeScript, or in this case also we're going to be able to compile our JavaScript, but it's looking for that file in our project. So the name is important, tsconfig.json. Now we can use this to configure some settings on the TypeScript compiler. We do this, and look at that. We get IntelliSense or autocompletion inside of this file, super helpful. Otherwise, I have to constantly go out to the GitHub wiki page that shows me what these properties are. But now I can do it, and I can be squishy-brained about it. So I could say compiler options, and then we're going to say target, and look at this. We can specify what we want to compile our JavaScript into whatever target. We can say ES15, or excuse me, 2015 or ES6, or more current versions, 2016, 2017. We can go all the way down to ES3. I'm going to say ES5. That's a good compromise. Then here's where some of the magic begins to happen. We can tell the TypeScript compiler, which normally just looks at compiling .ts or TypeScript files, we can say, hey, I also want you to compile the JavaScript files that you find in our project. Then I'm going to set my out directory, because I don't want to compile my JavaScript in place. It won't let me do that. It won't let me overwrite the JavaScript files that are my input files. So I have to direct the output to be somewhere else. So I can say www.root/scripts. Then I don't want every JavaScript file in my project to be considered as input, because I don't want the output of my www scripts to be included. So I'm going to add an include. An include just says, these are the paths, or these are the files that I want to be considered part of my TypeScript project. So now I can basically just say client, and that will include anything that's in the client folder or subfolders of that. So this makes up the totality of my tsconfig.json file, and now we're going to build. So I'm going to Control-Shift-B to kick off a build in our project. Oh, and we get lots of failures. So the one here that we need to pay attention to is this bottom one down here. It says duplicate content items were included. So this happened because I drag and dropped from www down into the client folder. So if we right-click on our project, and like you may have seen in other demos, in ASP.NET Core Web Apps, we can now edit the CS proj without unloading our project. Very slick. And notice that, oh, we have these content items, but there's some duplicates here. These look good. There's our app.js and data.js, but here's our models, and here's our models again. So I'm going to kill those two. And in fact, this one is no longer valid. Shouldn't even be there. And those look like our source files and our index. That's all good. Close this. Now do Control-Shift-B, and with any luck, our project will build successfully. And there we go. We have one succeeded. And you might have caught there real quick, but our scripts folder is back. Now these are the compiled files from our source JavaScript files over in client. Now you might be wondering, well, why bother? Well, let's take a look at this. If we go into, actually a good example is app.js. Notice inside of app.js, and I'll zoom in here just so you can get a closer look at this because it's kind of subtle, but I'm using backticks. And backticks is how you defined a template string in ES6 or ES 2015. That allows you to do these indices, and without having to do string concatenation. It's pretty slick. If you do any C# development, these will look familiar. So that's a newer feature. We recently got a complaint from a user of our web application or our website that they were using an older phone that had an older browser, and that didn't work. And they got an error. So now if we go look at app.js, the compiled file, notice that the template string has been removed and it just gets replaced with regular string concatenation. So this is an example of taking ES6 or ES 2015 features and we're down compiling it to something that is ES5 compatible. This also works for classes. So if we go look at our version, which is version.cs, which is a class, an ES6 class, if we go look at version over here, now in the compiled version, it has been converted into a constructor function. And add supported framework is attached to the prototype as you would expect idiomatic JavaScript to look like. Now, one thing I want to point out here is that notice that I have open version.js. That's the target file. That's the compiled destination. If I open up version here, And let's say I'm just going to add an x property. Actually, I'll do it up here. I'll say let x equals an empty string. And then I press Control-Shift-B. And the project compiled successfully. But if we come over and open our version.js, notice that that code didn't make it over. This is really easy to get frustrated by. You'll make a change, you wonder, why is my change showing up? So it turns out you can't have this file open. So let's go ahead and just close all of our open documents and open up version.js again, and we'll compile one more time. Now if we come over to version, we'll see let x there in our constructor function. So just a little footnote there, just make sure you can open up those files to take a look at what the compiled JavaScript looks like. Most of the time you're probably going to get used to not doing that. Just don't keep those files open, otherwise you'll end up in that frustrating experience of compiling, thinking that it's compiling and generating your target files, and it's not actually doing it. So the benefits of what we just did there, we moved our source JavaScript files out into its own folder. So now we have them outside of the www root folder. We added a tsconfig file so that we're configuring the TypeScript compiler, which allows us to do down-level compilation into ES5 or even ES3 if we wanted to do that. That gives us the ability, we're doing what Babel does without having to bring Babel in as a dependency, for instance. We're just getting this out of the box in Visual Studio with a little extra configuration and project setup. Not too difficult to do, and it's a really powerful development workflow. So what are some other things you can do? Well, you can also configure the TypeScript compiler to help you do to discover some common kind of errors in your code. So for instance, you can say allow unreachable code, and we can set this to false. Now if we come into, let's do it here inside of data, and let's just do a hard return inside of that function and compile. And boom, we get a lot of ESLint errors, but we also get a TypeScript error that says unreachable code detected. If we double click that, in fact, we're getting a little green squiggly there as well, letting us know that this code is not going to be executed because we're returning right above it. So that's an example of how you can begin to use the TypeScript compiler to catch some common errors. Another one that we can use is no fall through cases in switch. And if we set that to true, then we wouldn't be able to have a case statement that looked like this. So if our switch statement that looked like this. So if we said switch, and then let's just say, well, we'll just do something nonsensical here. And if we had case x, and then let's say we did something, so let z equals, and then case y, and then let z2 equals something, and we break there, then we should get an error on this as well, and we do. We have a fall through case in switch because we didn't do a break. So if we added a break here to keep it from falling through to the next case, then that should fix that error, and it does. So again, another quick example of how the TypeScript compiler can help catch probably something that you didn't intend to do and make your code cleaner and more reliable. So I'm going to go ahead and go back to tsconfig and pull those two things off because we don't need them going forward. So now we're down compiling to ES3. We have great IntelliSense. You might ask yourself, do I really need TypeScript? Well, let's take a look at an example here. And I'm going to look at these calls to this version constructor function. And notice that we're passing in a string here for the date, and then everywhere else down below, we're passing in a date. Which one is it, right? Well, our version class, remember, it right now says that release date can be any. So we're not constraining the type that we can pass. Well, as it turns out, our application ran into a problem trying to handle these, trying to display out a formatted date. Oops, opened up the wrong folder. Easy to do. So I'm going to close all documents, go back to Solution Explorer, and then I'm going to open up App from Client. In fact, I'm just going to collapse scripts here for a second to keep me from doing that again. All right, so here we can see that a developer did a hack because they were not sure that why calling to local date string was failing sometimes. Well, as it turns out, if release date string, if version.release date, that property on that object is a string, then this function doesn't exist on that type, so it was failing. What they did to work around this, and this is horrible, hence the hack comment, is they wrote a try catch around it, they logged the error, then they just said, well, I'm just going to set release date string to be version.release date and not even attempt to format it. And that sort of kind of worked, but that's not really, the kind of code that we want to be writing in our application. So to help with this, we can go ahead and move to TypeScript. So let's do this. Let's jump over to our project, and we're going to rename version.js, rename, and I'm going to change the extension to .ts. I'm going to confirm the change, and notice that our little icon changed to TS, helping us identify that it's now a TypeScript file. And right off the bat, we're getting some compilation errors. It's saying that property name does not exist on type version. Now, that was valid JavaScript, but TypeScript is a little bit more, wants you to be a little more explicit. It wants you to list out what your properties on this class should be. So I'm going to add name, code name, version number, release date, and supported frameworks. And that will make those errors go away. Oh, except that one is not. And we'll set this equal to be an array. Oh, it's because I misspelled supported frameworks. Yeah, it helps if I type the property name correctly. Okay, so now we're back, but we still have any data types. Well, we can do better. And to show that we can do better, let's jump over and look at some language features available to us within TypeScript. So I'm going to go File Explorer, go to my desktop. Here's my demos. And I'm going to use, just for convenience, I'm going to jump over to Visual Studio Code and show some examples over here. This is a single file project, not much to it. And then let's take a look at this simple example. So here I have an add function. It takes two parameters, number 1 and number 2. And here I'm calling add, passing in 1 and 2, getting a result and logging that result. If we hover over add, just like what we were seeing before in Visual Studio 2017, Visual Studio Code, which is using the TypeScript language service, is able to identify the name of the parameters, but it doesn't know what the data type should be for those. And what that means is that we could pass in a string, and this is perfectly acceptable because the data type is of type any. Well, that's not what we intended. So here we can add explicit data typing, static data typing to be clear. So I can say colon number to make that a number, and colon number to make that a number. And notice as soon as I did specify the data type for that first parameter, we got a red squiggly telling us that the argument of type, our string, ASDF, is not assignable to parameter of type number. Now this is a super simple example, but this begins to illustrate the power that the TypeScript language service and the compiler can bring by adding just a few optional static types. I'm going to go ahead and change that back to being a number, and now we're compiling again. So again, I say a few. Parameters are typically going to always need for you to be specific with what the data type, or explicit with what the data type is. But there's other places where the TypeScript compiler can infer what the data type should be. So here is a variable that's being declared and assigned all in one line. And notice that the data type is Boolean because it's able to know from the value that we're assigning to it what the data type should be. 0 gets a data type of number. String becomes string, of course. Here we're not assigning a value, so again, the compiler has to think broader. And it says, well, I can't infer it, so I'm going to say that it's any. Null behaves the same way. After this, any value could be put into that. Here we have an array of numbers, so the TypeScript compiler is able to infer that it should be an array of numbers. Or we have an array of strings. So that's type inference. And that works with return values as well. If we come back up here and notice that after we only added 2 data types for each of our parameters. If we hover over here, if you look over on the right, you'll notice a colon after the parameter signature and the data type and number. That's the return type for this function. Well, the compiler is able to look at what we're returning. We're taking 2 number parameters, adding them together and returning the result of that. And it's smart enough to know that the result of adding 2 numbers has to be a number. It can't be anything else. So we're getting type inference because of the operation that we're doing on those number variables, or excuse me, parameters, in order to infer the return type. Typing can extend to interfaces. So this is a TypeScript concept. And if you've worked in statically compiled languages like C# or Java, interfaces will be a familiar concept to you. For those of you who've only worked in JavaScript, think of an interface as a code contract. I can say that this interface, or this type, needs to include a number 1 parameter, or excuse me, property of type number, and a number 2 of type number. And it's going to have a function that takes 2 parameters, both numbers, and return a number. Here, I'm defining a function, and I'm defining an obj, an obj parameter of type myInterface. And then I'm able to say obj dot, and notice that I get auto-completion here, and real auto-completion, that's looking at that interface type and saying that, hey, there's an add method here, or there's properties that you can reference. I'm then calling obj.add and passing in the 2 properties on that. Here, I'm calling my function, and notice that I'm passing in what's called an object literal. And this object literal is creating an object that has those 2 properties, number 1 and number 2, and that add function. And I'm using Arial syntax here as well to keep it nice and concise, my code nice and tight and concise. Well, what happens if I were to pull one of these properties off? Well, notice that the shape of my object literal no longer matches the expectations set in the interface. And so the TypeScript compiler recognizes that and gives me an error and says that this object literal is not assignable to parameter of type myInterface. And it even gets more specific. It says property number 1 is missing in type, and again, my object literal. And then we can add that back, and we're back to compiling. Interfaces are a really great way to define the shape of data. So for instance, you may have a property bag, an object literal. This is the collection of properties, or maybe even callback functions that you're passing into a library helper function. Defining an interface for that parameter allows you to be very clear about your intent as to what should be passed on that object literal. In addition to interfaces, we can also do classes. So here is a class. It looks remarkably like an ES6 class because, again, TypeScript is a superset of JavaScript. It's not trying to reinvent the wheel. It's using the idioms that have already been established. Here's our constructor. Here's an add method. But here's a private hidden method. And what's interesting about this, so here I'm instantiating my class. I'm logging the properties. I'm calling add. But notice we have an error here. And if I hover over this, it says property hidden is private and only accessible within class, my class. I also have a read-only property. So I'm trying to reassign a value, and that's an error as well. Kind of glossed over that. Up here, that is accomplished by putting the read-only keyword right there on the property. So here's an example of TypeScript extending what a class can do. We also have the ability to have abstract classes and abstract members on classes in TypeScript so that when you inherit, you have to, well, one, an abstract class you can't instantiate an instance of, but when you inherit from that in a concrete type, you have to override those abstract members. And then lastly, we have this idea of a namespace, which really just takes our code and wraps it in an immediately invoked function that passes in a global object. It's like the revealing module pattern. That allows us to export a function and keep another function private so that we can explicitly define what we want to be visible to the outside and what we want to keep private to our namespace. TypeScript also understands modules. So if we were writing Node.js or if we were using something like Webpack in our front-end code, we can use a top-level export or we can use imports as well. And that will tell TypeScript that this file should become its own JavaScript module. That is a whirlwind introduction to TypeScript. There's much more to the language than what we're just showing here. But now, armed with what we've just seen, let's go back to our project in Visual Studio and let's finish converting or improving our new TypeScript class. Remember that we converted our model version.js to a version.ts to make it a TypeScript file. And we added our properties. But now they're currently all of type any, which doesn't really help us. But we can be more specific, so I can add explicit static types. I could say name :string for code name, version number, let's make that a number, and release date, we'll make that a date, and supported frameworks, we'll say this is of type framework, an array of that. We get an error on that last one. Well, if we think about what's going on here, we have a TypeScript file that's trying to refer to this constructor function over in the framework.js. And we need to, so to speak, because this type is being referred inside of that version class, which is a TypeScript file, this is an example of kind of a cascading change that we need to address. And the way that I'm going to address this is I'm going to go ahead, since this is a simple constructor function, I'm going to go ahead and change this to be a TypeScript file as well. And once we've done that, I'm just going to go ahead and switch this to be a class. So I'm going to say class framework, and then I'm going to add a constructor. And I'm going to use a special syntax. I can say public name string public version number of type, if I could type, number, and then some curly braces. And then we'll get rid of this. Okay, now it's compiling again. And if we switch back over to our version class, now it's happy. And now we could put our cursor on there, press F12, and we're taken over to our definition. If we come down here and look at this code, well, we have our JS doc, but notice that when we change to our TypeScript file, that JS doc information is no longer flowing into the IntelliSense. Well, we're in a TypeScript file, so we no longer need the JS doc. We can just add our explicit static typing here. So we can say string, name string, and then version number, number. And notice that when we hover over new framework, we're shown that the constructor takes a string and version number is a number. And if we tried to pass the wrong thing in here, so if I switch that to be a number, then we'll get an error saying that argument of type 2 is not assignable to parameter of type string, just like we were doing over in Visual Studio Code when we looked at those examples. Excellent. So we have two TypeScript files now, framework.ts, version.ts. Let's compile our project. Excellent. Let's go double check to make sure that those compiled. And so here's our framework, which has been turned into our class has been turned into a constructor function. Notice that our data types evaporated. Now this is because the TypeScript static typing is a design time concern. It's not something at runtime that even the browser's JavaScript runtime engine would even understand. So they just get stripped out or they evaporate out of our code. If we look at version, it's the same thing. So let's close all of our documents, make sure we shut that down. Okay, so let's run our application. We haven't run our application in a little while. Let's run our application and make sure that things are still working. There's our data. Let's go ahead and open up the developer tools. and switch to the console. And I'm going to reload our app here. Oh, and we're getting some errors. So we looked at this earlier. We're getting a type error, and there's something going on with our data. So let's take a closer look at that. Let's go ahead and stop our application, free up some space here. Let's go look at data.js. Now we have, inside of here, calls to our version class, and they're still displaying as any. Why is that? You know, I might have forgotten to add some data types. Oh, and sure enough, I did. So let's fix that. Name string, user error here, number, and then the last one was date. Okay, now if we switch back, oops, save our file. Now if we switch back and hover over version, we'll see from the static typing, explicit typing, inside of a TypeScript file, we're getting that information all the way over in our JavaScript file. Pretty slick. But we'll notice that we're not getting an error. Even though we're passing a string for that fourth parameter where it should be a date, we're not getting an error. And that's because the TypeScript compiler in a JavaScript file, while it's going to give us that IntelliSense information when we're calling a function or calling a constructor in this case, it's not going to treat that as an error because in JavaScript, well, you have that loose dynamic typing, and what we're passing is actually a valid operation to do. So how can we get around that? Well, we can keep going. We can say data.js, and let's go ahead and convert this to be a TypeScript file. By converting this to be a TypeScript file, now, once the compiler compiled our project, now we're getting that warning that says argument of type, the string February 1997 is not assignable to parameter of type date. And we can fix this. We can say new date 1997, and we'll just give it the first. Doesn't have a day, but we'll give it a first. And remember, the month is actually zero-based, so that's why I put in a 1 for February 1998, 5 for the month, and we'll give it the first as well. And then we'll come in here and pull that out. And now we're passing the expected correct data type. Let's go ahead and change our app.js to be a TypeScript file as well. And let's Control-Shift-B just to make sure that our entire project is building. Oh, and now we have more errors. Let's go check out and see what those are. Okay, so first of all, it doesn't know what jQuery is. Can't find that. We'll come back to that in just a second. But our hack is still up here, and we don't need our hack anymore. So let's move that code out to make the release date string. Get rid of this, because now we know definitively that release date is always going to be a date, because we've added that optional static typing. We know this is going to be a date, the compiler is going to help us enforce that, and we know that the toLocal date string is going to be available to us to call. So if we Control-Shift-F-B, okay, we still have that error with jQuery. Well, this is one of the drawbacks of adding or converting over to using TypeScript, is that we're no longer getting that very slick automatic recognition of the jQuery library. They call that automatic type acquisition. And when we switched to using over a TypeScript project, the automatic part of that went away. These TypeScript definition files live out in an npm scoped package called @types. So npmjs.com, ~types, and there's literally thousands of these npm packages. And what's inside of these are TypeScript interfaces and classes that define the API for these libraries using static TypeScript types. these packages are brought over from a repository in GitHub called Definitely Typed. It's completely community driven. Pretty much any JavaScript library that you likely use is going to be available up there on Definitely Typed. So in order to bring in the types that we need to go over to the command line. And, well, I'm going to use the command line to do this because that's how I'm used to doing it. I'm over in the desktop, and I have a demos folder, and then this is inside of demo. And we need to go further down here. We need to get all the way into the root of our ASP.NET Core project. And here we are. So I'm going to say npm init. This is done just once up front to initialize our project to use the npm package manager. Then I'm going to go out, no, that's not the right, clear. I'm going to go out and say npm install @types, which is that scope package, jQuery. And then I'm going to pass in the save dev flag. Save dev just means that this is a development dependency and not something that we need in production when we release our application. So that went out, grabbed that @types jQuery type definition file from npm and brought it in to our project. Now that we have that available to us, we do need to, when we add a new type definition like that, it's my experience that you might need to reload your project. So I'm going to reload the project, come back out here, and now we have back our type information, just like we had it before. And, I mean, to be clear, we had to go through the step of setting up npm. Not too difficult to do, but that's how we work around that. So now we have our full TypeScript project with all the goodness that brings. Our IntelliSense is back. We fixed a bug that we found in our application, so that's great. Again, if it was a larger application, we could choose when to convert our JavaScript files to TypeScript and not have to do it all at once. We could do it incrementally or just part of our project and leave the rest of it as JavaScript if we wanted to do that. And we still got the great JavaScript editor benefits that we had before. Let's finish up with a quick wrap-up here. Switching back to the slides. Oh, and of course, I'm started back at the beginning here. Fast forward. Here's our demos. Excellent, we did that. All right, wrap up. So here's some great resources. All of the demo code that I showed you today is available up on this GitHub repo, along with notes from my presentation. The official TypeScript website is a really great resource. So typescriptlang.org. They have great tutorials and great documentation on the TypeScript language. Don't miss that. If you're wanting to know more about JavaScript itself, so maybe you're relatively new to the features that are available in ES 2015 or ES 6, be sure to check out some of the courses we have available on Treehouse. We have an introductory course, ES 2015, and we cover some of the things like let and const and arrow function syntax and temperate string literals. And lastly, the company I work for at T-Chat, Treehouse, we offer a 7-day free trial. You get full access to our library, so you go check out some of our great JavaScript content, including a whole set of courses and workshops that will teach you React. So go to Team Treehouse today and start your learning. Thanks for tuning in and checking out this module on TypeScript. We'll see you around.